their home game against Pine Ridgeland. Please dismiss the 8th grade boys soccer team at 2:55 today for their home game against Hampton. Good luck, Foxes.
The DMS boys soccer team came away with a 2-0 victory at Mars on Friday. Both goals were scored by Jake Farmer, and the clean sheets were provided by Odin Strasser and Parker Imson.
Thursday is Cowboy and Cowgirl Day, and Friday is FC Crab Day. Have a great day, DMS!
All right, finally. So when I saw you Friday, we were reviewing slope. You did a pretty good job, okay? Reminders about slope. Slope is also referred to as that. What does that stand for? Rate of change. Very good. And we divide your change in y by your change in x. Okay, the graphs we talked about, you did a great job. Just reminder, please don't forget that a downward sloping line is nice negative. Taught this a long time, and I get a lot of students that clearly know that that's a negative line, and they forget to label a negative change, and they tell me the slope is 3/4. I don't know if anybody did that last year, but that's one of those how could I do that moments. Okay, good. Through the pair of points, I'm going to give you a couple options. Option 1, and again, you got to assess your work here, is to do what I did. I did the change in y over change in x. I showed what I'm subtracting. And then you get your answer. So you can do it the way I did it. I think I showed you on Friday. You could also do a mini table. So if I was doing that one. And then my x change is 4. My y change is -5. I have to see something. Okay? I don't need you to write out the slope formula every time. Change in y over change in x. Like, I don't need all that stuff. But I got to see this. Okay? You should also use m. M is universal for slope. Don't leave any doubt about what your work is. Some of you leave a lot of doubt. Okay? Just be careful. For 13 through 15, 13, those are the fractions. You can handle them. Same with 14. 15, while I gave you decimals, I gave you very friendly decimals. If I give you ugly decimals, I would provide you with a calculator. But that one, 15, I didn't feel like you needed one because they worked out clean. Actually, there's only one question on the whole homework where I would have felt the need for a calculator. 17, okay? That was the only one where, like, if I felt like I needed it, then I would have done it, okay? These were actually not just rates of change. You learned this last year. These were all lovely, wonderful unit rates. Unit rates are where you compare to 1. You see unit rates like your entire life. Miles per hour, dollars per pound, yada, 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 okay? How did the identifying of the independent and dependent variable go? We didn't really review that. That go okay? You learned that last year? Does she still do the thing where it says like meter swum and everybody argues whether or not swum is a word, or does she not do that anymore? Yeah, everybody gets mad because it's like swum. Yeah, I know. Okay. I usually tell people, hey, if you can't identify dependent and independent variable, I usually ask myself what has to exist for the other one to occur. So I'm looking at 17. 2 pounds of apples cost $3.98. Those can't be Honeycrisp. Anybody like Honeycrisp?
Yes.
So good, but they're way more expensive than that. Why is apples independent? There is no cost unless you're buying the apples. Okay, look at this one. The airplane ascended 3,000 feet in 10 minutes. Independent is time. If time doesn't pass, the airplane doesn't ascend. So if you really can't tell which one's independent and which one is dependent, just think to yourself which one has to exist without the other. Okay? Then finally the variable ones. I mentioned to you, slope dude, right there. I mentioned to you that these were new. I thought you did a pretty good job with them on Friday, but well, some of you aren't even looking at the questions, so I don't know what you really remember. But sometimes new stuff can be a little scary. So if I was doing the slope of that, these are my y coordinates. I can go in either order. -b minus -b. What is that going to give me? 0. But I don't know the bottom just yet. a minus negative a is 2a. I don't know what a is, but 0 over 2a does come out to be 0. We actually talked about this on Friday as well. What value can a not have? 0. Good. This one was a little bit spicier. I did this direction. N minus negative n on top, negative m minus 3m on the bottom. That landed me here. You might have thought you had it if you got it here, but you'd have to divide each of them by 2. Again, m's not allowed to be 0. This guy, there was actually no work to do. Once you subtracted it, you were done. C minus 2d over 2a minus c, you're finished. Okay, and then the last one, okay, you have to subtract. I wouldn't worry about the variable stuff too much. In general, as long as you know how to find slope, you're in good shape. If you don't remember how to find slope, you gotta get with it pretty fast because that's a bunch of stuff that we did. Okay, so let's go to 5-2. We're gonna take something you already know today and we're gonna rebrand it. I love a good rebrand. Yes, a rebrand today. Yes, do we know what a rebrand is in life?
Yeah.
What's a rebrand? Matthew, what's a rebrand? Redo your branding. That helps a lot. Okay. Okay. What? Well, you change the name, look, or something to try to get to be like something different. The one that's undergone the most rebrands in my lifetime is Dunkin' Donuts. It used to just be Dunkin' Donuts, then they try to just be Dunkin'. They also don't even advertise things anymore. Like, their big points of emphasis now, it's like their coffee drinks. That used to not be the case. They used to like really push their donuts. Then they rebranded. They tried to just be Dunkin'. It's actually it's a better organization than what it was. When I was your age, it was kind of like nobody went to Dunkin' Donuts. Now people all the time. Okay. So we're gonna rebrand something today. Okay, we're gonna talk about something called direct variation. I'm gonna guess you haven't heard of that, but you have because we're gonna rebrand it. Cross out the expression below that does not show a formula for slope. Okay, so it's hard to play yay or nay because we're crossing out the one that does not represent slope. Okay? Well, somebody give me one of the ones that does represent slope. Liza, which one is okay? This one? This one is good. So that one's good. There's another one that's good. Okay, Colin. Okay, so guess who's out? You can't do X change over Y change. You're too advanced for that. You did an entire pre-algebra class. You can't do it, okay? It would be Y change over X change. Ooh, we did this with slopes the other day. You're going to tell me the slope of a horizontal line is? 0. Because this is 0 fun. Whereas, redemption for a lot of you, the slope of a vertical line, which is not a curse word, they're trying to be funny, just a regular word, okay? Now every once in a while, they like to make sure we're using these terms properly. I call this fake literacy. I'm so good at fake literacy, you will learn right now. We're going to choose the correct word to complete each sentence. Okay, just watch how good I am at this, you don't even know. Renee gave the visitor direct to the museum. Right? Right?
Yeah.
The fans went directions. Okay, let's Alan. Let's stop. And there's a directly connection. 3 out of 3, right?
Yeah.
My English teacher mother would be proud. Okay, let's put the real ones in. Renee gave the visitors directions to the museums. How about the fans? What'd they do? Yay. And then there's a direct connection between the outside temperature and the number of people at the beach. I was close. Next time I got it. Okay. You're going to hear the word direct a lot today. You actually do know what a direct variation is. Okay, direct, or as they tell you here, direct. You've actually seen this before, but it's not what you know. In fact, when we talk about a direct variation, I'm going to wonder who knows exactly what it is once we start going. So let's go to the next page. Okay, some fill in the blanks. A direct variation is a relationship that can be represented by a function of the form, here's what you're filling in, y equals kx, where k is not equal to 0. You studied this last year, but you did not call it direct variation. That's why we're rebranding. Does anybody remember what you called it? You might remember already. It's okay if you don't know. Liza?
Wait, something for?
No. That's okay if you don't. Maddie? Nah, you would know already. Oh, you're on the right track. Okay, good job. Okay, you studied this last year. You called it a proportional relationship. You said constant of proportionality. Okay, so good news. All we're doing today is we're rebranding it. I'm going to remind you anyway. Y equals kx. You know why they chose k? Because it's the constant of variation. I'm not making it up. Mathematician's not that great. Okay? Okay, the constant of variation is k, and that's the coefficient of x. If you divide each side, you get the equation k equals y over x. So I want you to make a little note by this little paragraph. Okay, this is going to help you through the day. All of today is the same as proportional relationship. I know you studied those. I'm just going to rebrand it. We're going to give it a real big kid name. Proportional relationship, that's kind of baby stuff. We're going to call it the actual thing, direct variation. Now, some of you might be wondering already, isn't direct variation, which is y equals kx, isn't that just y equals mx plus b without the b? Yes. In fact, you learned last year that to be proportional, there were some restrictions. We're going to get into that now. So last year, you learned this as a proportional relationship, and k was called the, remember, usually everybody remembers, the constant of proportionality. The COP, yes, okay? That's not a term we use very much in algebra. I don't know why they want it to be in pre-algebra so badly. You do need to know it. But for us, we're going to call it the constant of proportionality instead. We're going to call it direct variation and the constant of variation. Okay. If you want to think of today as y equals mx plus b, where b is 0, you can. That's not wrong. Okay, but it does matter like quite a bit. Okay, so some of these questions are actually pretty straightforward, and then they throw a couple of loops at you. I might also review some calculator stuff with you. So, does each equation represent direct variation? If so, identify k. Let's look at the first one. 7y equals 2x. I could actually solve it pretty easily for y. What would I do? Divide each side by 7. That lands me here. Question to the group. Does that fit the form y equals kx? Yeah. And what's k? 2 sevens, not 2. 2 sevens. Yes, there it is. Okay. But what about this one? No. Now let's see if anybody remembers from last year. Anybody remember what this is called? You probably hated it. You probably hated it. I know that doesn't narrow it down for some of you still. Who says standard form? Hey now. Remember standard form? Why does everybody hate standard form so much? What do you do with it over there that makes everybody so mad? It's actually very useful. You just don't know why. You don't know why it's useful yet. You'll learn in a couple weeks. This is standard form. She shows it to you briefly. Most of you hate it. Go ahead, just be proud. Tell me if you didn't like standard form last year. Wow, a lot of you. Okay, great. Guess what? In a month, what's today? The 22nd?
Yes.
Oh yeah, yesterday was the Earth, Wind, and Fire Day. Do you remember the 21st? Okay.
Oh, yes.
Okay. All right. So it's September 22nd. 1 month from now, who hated standard form? Put them up. 1 month from now, most of you will not have your hand up. You'll like it. Right now you hate it. Question. Okay, question. Question. Is it linear? Yeah. Is it direct? No. Because if I solve it for y, this is probably what you had to do that you hated. Subtract 4x from each side, divide each side by 3. It's linear, but it does not fit the form y equals kx. Okay? So one of the things you learned last year, all proportional relationships are linear, but not all linear relationships are proportional. That's what you did. You learned about lines. Then you did like the walkathon with Gilberto, and that had a y-intercept. When I tell you I know that curriculum inside and out, I'm not kidding, okay? So, don't worry, if you forget, I remember for you. Does 4x plus 5y equals 0 represent a direct variation? We have to prove it. Okay, we're doing this one together. So how would you solve that one to see if it can actually be put into that form? I would maybe subtract the 4x over. So 5y is negative 4x, and then divide everybody by what? 5? So what's your equation? Y equals negative 4/5 x. Yes. This fits the form of a direct variation. And what is the k value? No, negative 4/5. Or somebody say 4/5. It is negative 4/5. Okay? Good. So the standard form stuff is not a big deal right now. It will become a big deal. I will convert a lot of you. You will grow to love it. Okay? Cool. There are 6 of them. I want you to decide, are they direct variations? If so, what is k? And if they're not, just write no. Go ahead and work on them together. Just like what we just did. Decide if they can be direct variations, yes or no. If the answer is no, you can just say no. If the answer is yes, I need you to put it in the right form and tell me what k is. Okay? Okay? Okay. Good job. Thank you. It's like the passive aggressive k. The person that types like k and then period, you know what I'm talking about? I do that. Because I type, when I text, I do like full grammar, spelling, punctuation, everything. Yeah. But sometimes the passive aggressive K. K. Period. You all do that, right? You all text in like complete sentences and punctuation. What about if you're texting your parents? That's different, right?
Oh, yeah.
Yeah. All right, let's go. All 6 of them. Come on, all of them. Yes or no? If the answer is yes, I need you to solve it for K. And tell me what, put it in the right form, and also tell me what K is. Keep that page open, we're not going to be done with it.
How'd you get that? I did it the wrong way. I did the wrong way.
Okay, I'm ready to go on. Yes. I don't know if anybody knows the top 3 were all no, the bottom 3 are all yes. I want to talk about the top row in a second. Wait, please don't backwards divide. You're always solving for y. Okay, so don't divide by don't divide by 7. Divide each side by 3. Y is 7/3. X, you have to identify k is 7/3. It's just the coefficient. Divide each side by 6. Y is -2, so k is -2. And then there's your half. Okay. Now, the top 3 were all no. The easy answer for why they're all no, they all have a y-intercept other than 0. Here's what you probably hated last year. I bet you she made you convert them. We're going to practice the converting now because it's going to come up in a month. You have to do it. It's going to help you a lot. But they're all no. Okay, so if all you wrote was no, you have to chime in on everything. Okay. If all you wrote was no, you did it right. That's what I was looking for. I want to practice the converting anyway. The first one's not bad. We're just going to divide everybody by 2. So what would you end up with? Y equals 5 has x plus 1 half. I need you to write this. I need you to write this. Now it's still not direct because of what? Which part? The half. But it's linear. I'm pretty sure that's what you hated last year about standard form. She made you put it in y equals mx plus b form. Does this help? Okay? Let's do this one. I need to solve it for y. What would your first step be? Subtract 8x from each side. So you're with me. 9y is negative 8x plus 10. And then you would divide everybody by what? So y is negative 8 ninths x plus 10 ninths. The answer is still no. I'm having you practice stuff that's going to help you in a month. Okay? The last one's the easiest. You just got to do one thing to solve for y. Subtract the 8 over. Good. Okay? You don't need standard form right now. We'll talk about it in like 2 weeks. And then in about a month, we will see standard form a lot. But by then, all of you will love it. Okay? But why were all of these no? Simple. All of these were no because they have this y-intercept, that y-intercept, and that y-intercept. Okay? Questions on that first section? Yes? No? You got to answer that one. Yes? No? Okay. Cool. Okay? So, what if they give you information and you have to write the equation from it? To write an equation for a direct variation, you first must find a pair other than 0, 0, and then solve. I like questions like this because everything just lines up. Suppose y varies directly with x. What that means is y equals kx, 100%. Y is 35 when x is 5. We put in 35 for y. We put in x for 5. How could you solve for k? Divide each side by 5. Boom, k is 7. The direct variation is y equals 7x. And then they want to know what's the value of y when x is 9. Plug it in, you get 63. I love questions like this. All you need to do is find the k value, and then you can get anything you want. They will almost never give you the k value, ever. They'll give you x and y. They'll ask you to plug them in, and then you'll solve. What do you think the biggest mistake on this problem is? Guess what students do? They switch x and y. And then the whole problem falls apart. Yeah, I guess that's like backwards dividing. But you need to put x and y in the correct spot, keep everything straight. Okay? So this little chart tells you how to approach a problem like this. Suppose y varies directly with x. Well, what does that mean? Y equals kx. Notice how I'm filling in the chart. How about that? And y equals 10 when x is negative 2. So we're going to substitute 10 for y and negative 2 in for y. Okay, so they plugged in 10 for y. They plugged in negative 2 for x. Who have we not solved for yet? Okay. How would you solve that next one for k? What would you do from here? Divide each side by negative 2. What's k? Negative 5 equals k. We're like almost done. Then you write your equation by plugging negative 5 in for k. Y is negative 5x. That's step 1. Step 2, I determine the value of y when x is negative 15. I'm just going to plug in negative 15 for x. You can do negative 5 times negative 15. You're big kids. 75. It's just plugging stuff in. But you have to plug stuff in into the right spot. Imagine an exam where you always plugged x and y in backwards. Probably wouldn't go that well. Okay? So if you're running into these questions later on your homework, you don't know how to do them, just look at this chart. This chart tells you how to do it. And you don't have to fill in the whole chart, but the chart is a nice like walkthrough of how to do the question. Okay? Now, I want to remind you of the graph. Okay, I think you don't have this picture because I didn't think you needed it. You have something similar. I want to remind you about these graphs because you learned a little bit about them last year. Weight on Mars, Y, varies directly with weight on Earth, X. Just without looking at anything. Do you weigh more or less on Mars than you do on Earth? Do you know? Why? That's all you need, gravity. Okay, good. So apparently, according to this, if you weigh 130 pounds on Earth, that's the same as weighing 50 pounds on Mars. Oh. Well, don't worry, we'll give you a chance to calculate your weight on Mars if you're interested in it, okay? But they're telling you it varies directly. Once you hear varies directly, you should be thinking y equals kx, okay? But notice how this can get very sticky, okay? We need to plug the correct weights into the correct spot. 130 is your weight on Earth, 50 is the weight on Mars. How did they solve for k? What did they divide by what? No, they didn't divide 130 by 50. See, if you backwards divide, the whole problem falls apart. Okay? And so the way that you calculate your weight on Mars, if you feel like it later when we get the calculators out, is you take your weight and then you multiply it by 0.38. That is what your weight on Mars would be if you're interested in finding it out later. What I want to remind you of, this is from last year, if something is direct, it must go through, I don't know if anybody remembers. Yeah, say it. Good, you don't have to write this, but it's going to come up. It must go through the origin. Okay, it must. Otherwise, it's not. That's where you learn direct variations are linear, but not all linears are direct variation. Because then you got Gilberto, and Gilberto's like didn't go through the origin. Yeah, Gilberto is like legendary. Okay, cool. So what I want to have happen, without this being a big deal, I'm going to review some stuff with you. If you have your own graphing calculator, you can use it. If you need one of mine, they're in the black case back there. Send somebody back and grab one. Okay, do not open it yet. Come on, let's go. Come on, quick. Crash course calculator review coming at you. Do not open them yet. Right now, I'm going to give you crash course graphing calculator review. Basically, I'm going to show you all the stuff you learned last year. If you forget, this is your chance to remember. Later in chapter 5, I'm going to show you stuff you never did with it. I told you at the beginning of the year, if you wanted to do more with the graphing calculator and you're like, that's it, this year we will do a lot more with it. Today, I'm going to show you everything that you needed to know from last year. In a couple weeks, I'll show you brand new stuff, okay? Now, if you're ever using mine, which you're allowed to use mine, okay, please keep them flat on the desk, okay? They are not phones. They should not be, like, people drop my calculators and it drives me nuts, okay? You can't do it, okay? So we're actually going to do the moon problem in just a second, but let's talk about your calculator. Go ahead and open it up, turn it on. Shh. No, you're not going to talk while I do this, because everything I show you today, you already learned. First thing you should always do is clear the memory on the calculator. I'll bet somebody remembers how to do it. Say it if you know it. Second plus 7, 1, 2. Clear it out. Should say ran cleared. You're good to go. That should be the first thing you do anytime you pick up one of mine. Okay. I also teach geometry. We do some weird things with them. If you have symbols in there you can't get rid of, that means you didn't clear the memory. Okay? What we're going to do is we're going to ultimately graph a line in a little bit. I'm going to remind you of a few things. We're going to be good. Okay, tuck that off to the side. You don't need it for another minute. Okay, let's do the moon problem. And we're going to then graph the moon problem on the calculator and remind you of everything. weight on the moon, y, varies directly with weight on Earth, x. That is so critical. This sentence means we can write that. Some of you are looking at this sentence, so I know you have no idea what I'm talking about. That first sentence tells us y equals kx. Perfect. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. We're going to find the equation for the direct variation, and then we're going to graph it. The most important part happens now. Where am I putting the 100 and where am I putting the 16.6? Lorenzo?
We're putting the 100 times K and the 16.6 is on the Y.
What do we think, everybody? Yes. Weight on the moon, y, varies directly with weight on the Earth, x. 100 here, 16.6 here. You putting those numbers in backwards, whole problem's going to be off, okay? How are we going to solve for k? We're going to divide each side. You actually don't need the calculator for that division. The decimal just slides twice. So what is k? Point. Okay. To the nearest hundredth, k is equal to 0.17. So y is about 0.17x. Okay, that wasn't hard. However, if you're interested in right now, you can take whatever your current weight is, multiply it by 0.17. That's how much you would weigh on the moon. If you feel like doing Mars, does anybody remember what Mars was?
0.38.
0.38. Okay, cool. Now, let's review all the calculator stuff. Ready? Okay. I'd pay extra careful attention, especially if you forget everything. We're going to graph this equation. Okay? The only way we can graph is to input the equation. And does anybody remember where we input equations? If you remember, tell me. Y equals. Go ahead, hit y equals. Okay, Lindsay here. We're going to enter that equation. I think it was 0.17. Anybody remember where the X button is? It's right here. You might have forgot from last year. I'm here to remind you. It's right there, okay? Boom. 0.17x. You hit graph. I can almost guarantee that when this happened last year, a bunch of you were like, wow, it's not that cool. It just put a line on the screen. But I'm sure when it happened last year, there was people in the class that were like, whoa. Maybe it is that cool, but there's your line. Okay? Shh. Now, is it linear?
Yeah.
Is it a direct variation? Because it goes through the origin. Okay, so like we're totally good. Okay? If I wanted to pull up the table, does anybody remember how you get the table? Second graph. There's your table. Okay? What if I wanted to skip to my weight? I'll just tell you. You want to guess how much I weigh? If you want to guess, I don't care. I'm not offended. 300 pounds? 180 is pretty good, actually. More or less, that's about where I am. If I wanted to skip 300. 200. He's an NFL lineman. If I wanted to skip to 180, does anybody remember how you do that? Without scrolling all the way to 180? Second, by the way, you should be doing this. Second window, which is called table set. And then I'm going to go down to delta table if I wanted to change it. But right now, I just want table start. I'm just going to start at 180. 300. Yeah, 300. Okay. I would be 30.6 pounds on the moon. Let's go back to what Eliza just told us. Second table set. What if I wanted it to skip by 5s? That's where delta table comes in. Go to delta table, skip by 5s. And now it's the same value starting, and then it skips ahead by 5s. Okay, all that got covered last year. Now you probably made a ton of mistakes. You forgot where to put x. I'm going to go ahead and guess a lot of you screwed up the subtraction versus the negative sign. Anybody do that? Okay, those are all growing pains. The only other thing that she taught you was if I put a random line on here, but we'll review this stuff next week. She probably taught you how to do that intersection. Yeah, okay. I'm not going to review that with you now, but that's actually going to come up at some point in the next week or so. That might be all you learned, unless she also did the mean, median, mode, and range stuff. Did she do all that with you?
Yeah.
Okay, whatever. Is that the extent of your graphing calculator background? It probably is. Okay, cool. So I wanted to remind you that keep the calculators out. We're going to need them for a moment. But you input equations into y equals. You hit graph to see it. Second table pulls the table up. And then if you want to adjust the table, it's table set. Now you can answer all those fun questions like, how does it show up in the graph? How does it show up in the table? You know the ones I'm talking about. I'm not throwing those at you. I'm just kidding. Okay? Cool. All right. And if you really think I weigh 300 pounds, then just for fun, I'd be 51 pounds, it looks like down there.
Still a lot.
Yeah, that other equation is just extra. Okay, cool. All right, let's finish up. Finish up. Okay. So, we actually have to make the graph now. So, we're going to do what we just did. So, y equals 0.17x. Okay, we're going to fill in this. We're going to multiply all of our x values by 0.17. Oh, I'm going to use that feature we just talked about. Because what are they going by, 25s? Oh, so you know what? So let's do this. Because I didn't tell you to delete that. Okay, so I'm going to delete out my extra equation. So how do I make the table start at 0 and go by 25s? Second table set, start at 0. Delta table by 25s. And I can just copy. Now there's a skip. I think there's a skipped one. Isn't there? Yeah, there is. Yep, that's okay though. So we'll go 25. You should be copying these, but some of you just really don't take notes. So 4.25. What's 50? 8.5.
Yeah.
Then we skip to 100. What's that? 17. Then we skip to 125.
21.15.
Okay. Cool. Now, the graph. How many points do you need to make a line? 2. That's it. Well, I'm going to put 0, 0 on there. And I don't really have a lot of good, clean points on here, I suppose. 17 is probably our best bet. So let's go over to 100. Okay, 17 is going to be, this is 16, so then halfway there. And then please locate some kind of straight edge near you. We're not getting mine out. And then make this line. I could have plotted all of them if I wanted, but through 2 points, there's only one line. So why would I do more than I needed to? The other ones were all along the way. Cool. How's it look, all right? Okay. So we talked about the equation. We just talked about the graph. There's only one left. The table, very good. Okay, we actually went in reverse order of table graph equation. Table's not too bad. You can rewrite a direct variation of y equals kx as y over x equals k. Here's the problem. If I give you this table and I ask you, is it a direct variation? A lot of you will start doing this. Like out of habit. Talk with somebody around you about why that might be a problem when checking for direct variations. Why might this be a problem? Go ahead and talk about it. Because it might be a problem.
How do you know? Lily just said it like exactly proof.
Any thoughts? Why might this be a problem? Because I know she had you do this. Got a hand her.
Have that thing.
Go ahead, Katie.
Shh. It's different for like each time you do it up, so you don't know what's going to happen.
Okay, it's different each change. That could be a problem. It's not the one I'm thinking of, but it still could be a problem. Okay?
It can still be linear without being direct.
Okay, very good. Here's the problem. You're so programmed. I love that you come to me, these little programmed pre-algebra robots. Like, it warms my heart. But sometimes it leads to problems. This is checking for linear. We've been saying it all class. Just because you're linear does not mean you are Correct. So you might think it's direct even though it's not. So I actually don't think I would check it this way. To be direct means y over x is the same value every time. 6 divided by 4 is 1.5. 12 divided by 8 is 1.5. 15 divided by 10 also 1.5. This guy is y equals 1.5x. Versus this one. If I divide y by x, I get different values every time. This is not a direct variation. Okay? So I would be careful. I would not be doing this little change thing, even though you're programmed to, because that's not what we're checking. So if we were doing this one, for the data in the table, does y vary directly with x? I would simply do all the ratios. Okay? And we're checking y divided by x. So I'll check the first one. So what's 2.25 divided by -3? Okay, so I didn't prove anything yet. Let's do the second ratio. -0.75 divided by 1. That's easy. Okay, I'm like almost there. What's our last one? Oh, how did we do? Direct? Equation?
Y equals -0.75.
Or, yeah, -3/4, so -0.7. Okay. So just be careful. Just because you're linear does not mean you're direct. You have to be direct. Y equals kx for sure. Okay? There's 3 of them. Go ahead. You can work solo or together. If it's direct, write an equation. If it's not, tell me why not. Remember, direct is the same as proportional, but we're big kids now. And there's also indirect.
First one is a direct.
First one, second one.
First one, yay, nay?
Yay.
Equation?
Y equals
Beautiful. What happened? There it is. Good.
The second one also gains the paper.
Second one, yay, nay? Yay. Equation?
Y equals 1.8x.
I would also take the fraction. I think the fraction, what is it, 9/5? We're both fine. Last one.
Nay.
Now you kind of know it's nay right away.
3 times 2.
There's no way 1 divided by -2 can't possibly be the same as 6 divided by 3. So you already know that's not the case. However, this is what I want to point out to you as being dangerous. It is linear. It's y equals x plus 3. So you need to get this like really, really down. To be direct means you're linear, but you have to go through the origin. It's got to be y equals kx directly. It cannot have a y-intercept of anything else. Okay, so don't fall for that trap. Okay, good. So I want you to write this note by the bottom, and then we're pretty much done. All direct variations are linear, but not all linear relationships are direct. Please make that note. I know I said it a bunch today, but I feel like it's not anywhere in your notes. I need you to put it down. This is the kind of stuff we're doing in geometry now. It's true in one direction, but not the other. It's like a square's a rectangle, but a rectangle is not a square.
Yeah.
Those are called conditionals. You'll study them in geometry. Some of you will love them, some of you will hate them. That's all right, though. Any questions? Cool, I got 2 spicy questions for you. I want you to discuss. You can just do them at the bottom. Or first one. See if you can figure it out together.
Yes.
It's not a yes or no question. You got space at the bottom, you can do it. Here, you can talk about it. Come on.
How does y plus x to the power of 2 when x, if x equals 2, that's just
Oh, this is confusing, but I
It's actually not bad. Just a little extra spicy, but not too extra spicy.
Alrighty. I got 18 too.
There's another one we're going to do that's like this too.
Alrighty. I understand.
Oh my, I don't
It's
know.
just a bunch of fancy words we need to determine to be this super simple equation.
Oh, it's 18.
Whoa!
Oh, it's 18. I get it now. I get it.
Okay, so let's look at it. Then I have another one for you. So, y varies directly as, what did I put instead of x? We put what? There's really not a reason to panic, actually. It's business as usual. Y is 8 when x is 2. Find y when x equals 3. Let's just start with the answer, and then we'll backtrack and talk about how it is, what it is, or how we got it. Does anybody feel confident we got the final result? Sophia? It is 18. Anybody get 18?
Yeah.
Okay, now watch. If you didn't, I'm going to give you another shot here. Instead of y equals kx, just do y equals kx squared. Plug in 8 for y, 2 for x. You have to square the 2. Y is 2x squared. And then what's the finishing touch? Plug in 3 for x. Y equals 2 times 3 squared. Now don't do all this hard work. Don't do all this hard work and then make 3 squared into 6. Come on. 3 squared is 9 times 2y is 18. It's actually not that bad. You look at it, you're like, oh my gosh, the big thinking emoji, this is going to be hard. You just start here instead of y equals kx. Try one more. Good thing we rebranded. If you get something, compare it with somebody around you if they're up for it, see if you got the same end result.
I haven't got it.
I got 16 over 9.
It's pretty straightforward.
I don't think they minus subtract 5. I think they multiply.
All right, any takers? Final result? Final result. Delphina? 16 over 9. Starts out just like the last one. Y equals kx squared. Hey, plug in the 3 and the 4. Don't forget to square the 3. So k is 4 ninths. The whole thing is y equals 4 ninths x squared. then you just plug it in and finish it off. Hey, if you can do these, you can do anything that's going to come across on your homework. Okay? This is the key part. Y varies directly. If they say x is that, if they say x squared, they could throw almost anything at you. Okay? Questions on anything? I'll get your test back to you on Wednesday as well. We'll find with BL square. Wednesday's actually a very short lesson, which should be good. Just make sure this guy is in by Wednesday. We'll be good. Okay? And you can use a calculator on this. If we use one in class, you can use one on the homework. That's good. The deal.